Hello there, and welcome back to another quiet night of sleepy science. Tonight, we are going to drift out past the edge of the world you know and spend a long, calm while thinking about the oldest question anyone has ever asked while looking up at the dark. Are we alone? Somewhere out there, among more stars than there are grains of sand on every beach on Earth, is anyone else looking back? You do not have to solve anything tonight. You do not have to decide what is true. These are quiet facts about distant worlds, strange chemistry, patient searches, and the careful things scientists actually know, alongside a few gentle guesses about what might be waiting in the deep. Sometimes the sky feels empty. Sometimes it feels crowded in ways we cannot yet see. And sometimes the truth is simply that we have only just begun to look. In this long, slow video, we will wander through the numbers and the nearest worlds, through the tiny building blocks that life is made from, through the search for signals, the recent files opened by governments, and the soft question of what other living things might even look like. If these calm nights help you rest, you are always welcome to like, subscribe, or leave a quiet thought below whenever it suits you. But for now, there is nothing to do. Let your shoulders drop. Let the day loosen its grip. Notice how heavy your eyes are becoming. And as the room grows still around you, come with me out into the soft and endless dark. Let's begin. The night sky you look up at is almost entirely a picture of the past. The light from most of those stars left them long before you were born, and some left before there were people at all. When you gaze upward, you are not seeing the universe as it is now. You are seeing it as it was. Each point of light arriving after a journey of years, centuries, or millions of years across empty space. A star that looks steady tonight may have changed completely by the time its light reached your eyes. In a way, the whole sky is a kind of memory, gently glowing above the rooftops. And so, when we ask whether anyone else is out there, we are really asking about a place made of distance and time as much as space. It is a comforting thought in its own strange way. The question is old and patient, and it has been waiting in that ancient light for as long as anyone has bothered to wonder. Tonight, we get to wonder with it, softly, without any hurry to reach an answer. Our own galaxy alone may hold more planets than there are people who have ever lived, many times over. Astronomers now think the Milky Way contains at least 100 billion planets, and quite possibly 2 or 3 times that number. Each one is a real place, with its own weather, its own colors, its own long, silent history that no one has ever witnessed. Some are frozen, some are burning, some drift through storms that have raged for millions of years. When you try to picture 100 billion of anything, the mind quietly gives up, and that is all right. The point is not to count them, but to feel how much room there is. In all that space, across all those worlds, the idea that Earth is the only one where something ever stirred begins to seem like a very large claim. We do not know the answer, but the sheer number of worlds is the first soft reason so many scientists keep looking. And it is a gentle place to rest your thoughts as the night settles in around you. Scientists have now confirmed more than 6,000 planets orbiting other stars, and the count keeps rising almost every week. These are called exoplanets, worlds beyond our own solar system. And by the middle of this decade, the confirmed total had climbed past 6,300. Thousands more wait in a long list of candidates, likely real, but not yet fully checked. Each confirmed planet is a small triumph of patience, teased out of tiny flickers of starlight by people who may never see it with their own eyes. Not long ago, we knew of none at all beyond our own family of planets. Now they are almost ordinary, discovered so often that most never make the news. Think of that shift for a moment. Within a single human lifetime, the sky went from holding 0 known worlds to holding thousands. The universe did not change, only our ability to notice did. And there is something quietly hopeful in that, the sense that the emptiness was never empty. It was simply waiting for us to learn how to look. The first planet found circling a sun like our own was only confirmed in the year 1995. Before that, The idea that other stars had planets was reasonable, even expected, but no one had ever actually caught one. Then 2 astronomers noticed a distant star wobbling ever so slightly, tugged by an unseen companion. That companion was a planet, a huge one, whipping around its star in just 4 days. It rewrote the textbooks overnight. What feels remarkable now is how recent that all is. Many people alive today are older than the entire science of known exoplanets. The whole field, with its thousands of worlds and its careful maps of distant skies, is younger than a lot of the trees in your neighborhood. It reminds you that discovery is not something locked away in the past. It is happening right now, quietly, in observatories around the world, while most of us sleep. Tonight is simply one more night in a long, unfinished search, and you get to drift off knowing the looking is still going on. Roughly 1 in every 5 stars like our Sun may host an Earth-sized world in the gentle zone where water could stay liquid. That is not a wild guess. It comes from careful counting of the planets we have already found, and then reasoning about the ones still hidden. When astronomers do the arithmetic across the whole galaxy, the numbers become almost dreamlike. There may be something like 11 billion Earth-sized worlds in comfortable orbits in the Milky Way alone. If you include the small, cool red stars, that figure climbs higher still. 11 billion places where a warm ocean is at least possible. We do not know how many of them actually have water or air or anything alive. Most may be barren and quiet. But the room for life, the raw number of chances, is staggering. Picture 11 billion sunrises happening right now on worlds no one has ever named. Some over oceans, some over bare rock. Each one real, each one turning slowly in the dark. You do not need to hold the number in your head. Just let it be large, and let it be soft, and let it carry you a little further toward sleep. Beyond our galaxy lie perhaps 2 trillion more, each one filled with its own uncountable stars. The Milky Way is enormous, but it is a single island of light in an ocean of other islands. When telescopes stare at a patch of empty-looking sky for long enough, that darkness fills with faint smudges, and nearly every smudge is another galaxy, holding billions of suns of its own. The current estimate reaches into the trillions. It is a number that has no real meaning to the human mind, and perhaps it is not meant to. What matters is the feeling it leaves behind. If life is even fantastically rare, 1 living world for every million dead ones, the universe would still be quietly teeming. We simply cannot see across those distances well enough to know. So the honest answer, for now, is that we do not know. But the scale of it all is a strange kind of blanket. It makes our worries small and the night wide, and it lets the mind loosen its hold on the day. To think clearly about all this, one scientist wrote down a simple equation, not to give an answer, but to organize the wondering. In 1961, an astronomer named Frank Drake sketched out a short line of multiplication. It listed the things you would need to know to guess how many talking civilizations might share our galaxy. How many stars form? How many have planets? How many of those could support life? How often life appears, becomes clever, and learns to send signals? Drake never claimed to solve it. Most of the numbers were unknown then, and several are still unknown now. The value of his equation was never the result. It was the way it turned an overwhelming mystery into a set of smaller, gentler questions you could actually think about one at a time. It gave the wondering a shape, and that in itself was a quiet gift. Even now, scientists use it less as a calculator and more as a map of their own uncertainty. Tonight, you can simply let each unknown drift past, like a soft, unanswered thought before sleep. There is a famous puzzle in all of this, and it began, so the story goes, over a casual lunch. A brilliant physicist named Enrico Fermi was chatting with colleagues about flying saucers and distant stars when he paused and asked a simple thing. If the universe is so vast and so old, and life should be so possible, then where is everybody? The galaxy is billions of years old. A patient civilization could have spread across it many times over by now. And yet the sky, so far, is silent. no clear signals, no visitors we can confirm. That gap between what seems likely and what we actually see is now called the Fermi paradox. It is not proof that we are alone. It is simply an honest tension, a question mark hanging in the quiet. Maybe life is rarer than we think. Maybe it is common but shy, or brief, or simply too far away to hear. There are dozens of gentle explanations, and we will drift past several of them tonight. For now, just let the question rest lightly. Where is everybody? No one is asking you to answer, only to wonder. The comfortable band around a star, where water could stay liquid, is often called the Goldilocks zone. Too close to the star and any ocean would boil away into vapor. Too far and it would freeze solid as stone. But there is a middle ring, not too hot and not too cold, where water could pool and linger on a surface. Scientists borrowed the name from the old children's story, where one bowl of porridge was just right. It is a cozy image for a serious idea. Water seems to be one of the great keys to life, at least the only kind of life we know. So finding worlds in that gentle ring is a first place to look. Of course, being in the zone is only a beginning. A planet also needs the right air, the right chemistry, a steady enough star. Many worlds sit in the Goldilocks ring and are surely lifeless. Still, it gives the search a target. Somewhere out there, a planet is drifting in its own just right orbit, with water lying quietly under an alien sky. And you can picture that calm, distant sea as your breathing slows. Most stars in the galaxy are not bright suns like ours, but small, cool, long-lived embers called red dwarfs. They are dimmer and far more common, making up perhaps 3/4 of all the stars around us. Because they burn so slowly, they can live for many billions of years, far longer than our own sun will. That patience is interesting, because life may need a great deal of time to take hold and grow complex. A red dwarf offers an enormous, steady stretch of it. There is a catch, though. To stay warm enough for liquid water, a planet must huddle very close to such a faint star, and that closeness brings its own troubles, like flares and locked rotations. Scientists are still gently arguing about whether these common little stars are good homes for life or harsh ones. What is certain is that if life can manage around red dwarfs, then the number of possible living worlds grows enormous, simply because there are so many of these stars. Around us in every direction, these quiet embers glow on, keeping their long, slow watch through the dark. Around one small, cool star, some 40 light-years away, astronomers found not one planet, but 7, all close to the size of Earth. The system is called TRAPPIST-1, and it is one of the most remarkable things we have found. 7 rocky worlds, circling a dim red star, packed together far more tightly than the planets in our own family. Several of them sit in or near the zone where water might survive. If you stood on one of them, the neighboring planets would loom large in the sky, close enough to see as clear disks rather than tiny points. Imagine looking up and watching another whole world drift past, near enough to notice its colors. We do not know if any of the 7 hold water or life. Telescopes are still slowly studying their air, one careful measurement at a time. But the very existence of such a crowded, orderly little system tells us that nature builds worlds in ways we are only beginning to imagine. Somewhere out there, 7 quiet planets keep circling their small red sun, in a dance that began long before us and will continue long after tonight. Many planets around small stars are likely locked in place, with one side in eternal day and the other in endless night. When a world orbits very close to its star, the star's gravity can slowly grab hold and stop it from spinning freely. The same face ends up always pointing inward, the way the moon always shows us the same side. On such a planet, half the world would bake under a sun that never sets, while the other half would freeze in a darkness that never lifts. It sounds harsh, and much of it might be, but scientists suspect there could be a gentle ribbon between the two extremes, a ring of everlasting twilight where the temperature is mild and steady. If life existed there, it might cluster in that soft band of perpetual dusk, never knowing bright noon or true night, only a calm, unchanging glow on the horizon. It is a strange and beautiful picture. A whole living world gathered along a single line of dawn. As your own night deepens, you can imagine standing in that quiet twilight, where the sun rests forever just above the edge of the world. Some distant worlds may be covered by a single deep ocean, wrapped in a thick sky of hydrogen, a type scientists have started calling Hycean planets. The word blends hydrogen and ocean, and it describes a place quite unlike Earth. Picture a world larger than ours, its entire surface one endless sea, held under a warm and heavy atmosphere. In theory, such planets could stay mild across a wider range of orbits than rocky worlds like ours, which makes them intriguing places to search. One much-studied example, a planet about 120 light-years away, has become the center of a long and careful debate. Telescopes found gases in its air, and for a while, some wondered whether one of them might hint at life in a hidden ocean. But other scientists looked hard at the same data and were not convinced. The signal was faint, and the same gases can form without any life at all. That careful back and forth is science working exactly as it should, slowly, honestly, refusing to leap. We do not have an answer. But the idea of a warm world sea, dark and endless under a hydrogen sky, is a lovely thing to hold as you drift. There's a whole class of planets bigger than Earth but smaller than Neptune, and strangely, we do not have a single one in our own solar system. Astronomers call the rocky ones super-Earths, and they turn out to be among the most common worlds in the galaxy. That is a curious thing to sit with. The most ordinary type of planet out there is a type we have never seen up close because our own family skipped it entirely. A super-Earth might have stronger gravity than ours, thicker air, taller mountains worn low by their own weight. Standing on one, you might feel heavier, your steps slower, the horizon curving differently. Some may be rocky and dry, others draped in oceans or ice. We know they are out there in great numbers, but we can only guess at their surfaces from a distance. It is humbling in a quiet way. The universe's favorite kind of planet is one we are still learning to picture. And so much of what waits out there does not fit the neat categories we grew up with. The cosmos keeps its own catalog, far stranger than ours. Other common worlds are smaller versions of Neptune, wrapped in deep atmospheres with no solid ground to stand on at all. These mini Neptunes are little gas and ice worlds, more air than surface, their thick skies pressing down into a hot, murky haze far below. If you tried to descend through one, there would be no moment where your feet touched land, just gas growing thicker and warmer, then a strange, slushy layer, then perhaps a small, rocky core buried at the very center under crushing pressure. Life as we know it seems unlikely in such a place, though the upper clouds, milder and calmer, are sometimes mentioned as a long shot. What matters is how these worlds stretch our sense of what a planet can be. Not every planet has a shore, a ground, a place to stand. Some are simply enormous balls of weather, all the way down. When you look at the planets in our own sky, so tidy and familiar, it is easy to forget how unusual they might be. The galaxy is full of soft, hazy giants, turning silently, with nothing solid inside for a very long way. Some planets orbit so close to their stars that their surfaces are oceans of molten rock, glowing red in the dark. These are the lava worlds, and they are as extreme as anything we have found. Circling their stars in a matter of hours or days, they are scorched to temperatures that would melt stone. On the star-facing side, the ground itself may be a shimmering sea of magma, with clouds of vaporized rock drifting overhead and raining back down as tiny droplets of stone. It is a hellish picture, and yet there is a terrible beauty to it. A whole planet aglow, its surface churning like a slow furnace. No life could survive there, at least none we could imagine. But lava worlds teach us about the outer edges of what is possible. the places where planets meet their stars too closely and pay the price. They remind us that not every world is gentle, and that the same nature which builds calm blue oceans also builds seas of fire. Somewhere out there, one is glowing right now, quietly, in a corner of the galaxy no one has ever named. In theory, some planets could be built around carbon instead of ordinary rock, with interiors rich in graphite and even diamond. This is more of a careful idea than a confirmed sighting, but it is a real possibility scientists have explored. If a planet formed in a place with more carbon than oxygen, its chemistry could tilt in a strange direction. Instead of the silicate rock that makes up Earth, its layers might hold carbon in dense forms, including diamond squeezed hard by the pressure deep inside. A world with a heart of diamond sounds like something from a storybook, and we have no confirmed example yet. But nothing in physics forbids it. The universe is generous with its ingredients, and it does not always mix them the way it did here. Picture a dark planet, its buried depths glittering under unimaginable weight, a treasure no one will ever hold. It is the kind of quiet, harmless wonder that is pleasant to think about at the end of a long day. Somewhere, perhaps, such a world is turning, and the diamonds inside it will stay hidden in the dark, patient and unseen, for as long as the planet exists. Not every planet has a star to call its own. Some drift alone through the darkness between the suns, with no light and no fixed home. These are the rogue planets, cast out of their birth systems long ago, or perhaps born free in the cold. They wander the galaxy in perpetual night, unbound to any star, moving through the vast emptiness with only the faint glow of distant suns upon them. There may be billions of them, more numerous, some suspect, than the stars themselves. It sounds unbearably lonely, and on the surface it is. Yet even a starless world need not be entirely frozen through. Heat left over from its formation, or warmth from within, might keep a hidden ocean liquid deep beneath a frozen crust, sealed away from the cold above. Life, if it ever arose there, would never know a sunrise. It would live entirely in the dark, warmed only from below. Whether such a thing is possible, no one can say, but the image lingers gently. A silent world, adrift for eternity, carrying a warm, secret sea beneath its ice, sailing on through the night with no destination at all. Some of the very first planets ever found were not around living stars at all, but circling the dead remnants of stars that had already exploded. Back in 1992, before the first world was confirmed around a sun-like star, astronomers detected planets orbiting a pulsar, the tiny, spinning corpse of a star that had died in a supernova. It was a shocking place to find planets. The parent star had already blown itself apart, bathing everything nearby in intense radiation. And yet there were worlds there, circling the dense little cinder left behind. Whether they survived the explosion or formed afterward from its debris, no one is fully certain. They are surely lifeless, scoured by a harsh and steady glare. But their discovery carried a quiet message that we would hear again and again. Planets are almost everywhere. They form in gentle places and violent ones, around bright stars and dead ones, in conditions we would never have guessed. The universe seems to make worlds at every turn, even in its graveyards. It was an early hint that the sky was far more crowded with planets than anyone had dared to hope. Some worlds enjoy not one sun in their sky, but two, circling a pair of stars locked in a slow embrace. Astronomers have found real planets orbiting double star systems, and they are as evocative as they sound. From the surface of such a world, you might watch two suns rise together, or one chase the other across the sky, casting a double set of soft shadows on the ground. The stars themselves orbit each other, and the planet orbits both, threading its long path around the pair. It once seemed that such an arrangement would be too chaotic for a stable world, that the two stars would fling any planet away. But nature found a way, and these two sun worlds are real. Whether life could take hold under a double sunrise, no one knows. The lighting would be complex, the seasons strange, the shadows always shifting. Yet the mere fact of it stretches the imagination in the gentlest way. Somewhere out there, a planet is turning beneath twin suns right now, its long twilights doubled, its dawns arriving in pairs. It is a quiet, cinematic thought to carry with you as the room grows dark and still. The living things on Earth are built almost entirely from a handful of very ordinary ingredients, and those same ingredients are scattered all across the cosmos. Your body and every tree and beetle and fish is mostly carbon, hydrogen, oxygen, nitrogen, with a little phosphorus and sulfur mixed in. These are not rare, precious elements. They are among the most common in the universe, forged inside stars and flung out across space when those stars died. The very atoms in your hand were once inside a star. That is not poetry, it is chemistry. And it means the raw materials for life, at least Earth's kind of life, are available almost everywhere you look. This is one of the quiet reasons scientists suspect life might not be unique to us. The cosmos is not stingy with the building blocks. It spreads them freely through every galaxy and cloud. Whether those pieces ever come together into something alive is the great unknown. But the ingredients are there, waiting on countless worlds. When you drift off tonight, you can rest in the knowledge that you are made of the same stuff as the stars. And so, perhaps, is whatever else is out there. Rocks that fall from space sometimes carry the ingredients of life already inside them. When certain meteorites are cracked open and studied, scientists find amino acids, the small molecules that link together to build proteins in living things. One famous meteorite that fell decades ago held dozens of different amino acids, some common on Earth and some not. Crucially, these were not contamination from our planet. They formed out in space, in the cold cloud that made our solar system, long before Earth existed. That is a remarkable thing to absorb slowly. Some of the chemistry that leads toward life does not need a planet at all. It can happen in dust and ice, drifting in the dark, and then rain down onto young worlds ready-made. It does not prove that life is common. Making an amino acid is a long way from making something alive, but it shifts the odds in a gentle direction. The pieces are being assembled out there on their own, without anyone's help, in the quiet between the stars. And every so often, a piece of that ancient chemistry lands softly on the surface of a world like ours. Spacecraft have now flown to distant asteroids, scooped up samples, and carried them home. And inside those samples were the building blocks of life. In recent years, missions returned tiny amounts of dust and grit from small worlds far out in space. When scientists carefully examined these grains, they found organic molecules, including some of the very chemical letters that spell out the code inside living cells. Again, this is not life itself. It is the alphabet, not the story. But finding that alphabet, freshly delivered from an untouched asteroid, told us something reassuring. The chemistry that led to us is not a strange local accident. It seems to be woven into the ordinary material of the solar system, present in the leftover crumbs from which planets were built. If those crumbs carry such pieces here, they likely carry them elsewhere too, around other stars, in other systems. The recipe's ingredients appear to be common. What remains mysterious is the cooking, the rare and delicate steps that turn lifeless chemistry into something that grows and breathes. Tonight, we can simply enjoy knowing the pantry of the cosmos is well stocked, and let that be enough. Water, so precious and familiar here, turns out to be one of the most common substances in the entire universe. It is easy to think of water as something special to Earth, our blue rarity in a dry cosmos. But water is made from hydrogen and oxygen, two of the most abundant elements there are, and the two combine readily. So water is everywhere. It floats as ice in cold clouds between the stars. It coats distant moons in thick frozen shells. It rises as vapor in the air of far-off planets. There is water locked in comets, buried under alien deserts, hidden in oceans beneath frozen crusts. The universe is not nearly as dry as it looks from here. This matters because life as we know it leans heavily on liquid water as the place where its chemistry unfolds. If water were rare, the odds of life would shrink. But water is not rare. It is nearly everywhere in one form or another. The challenge is finding it in liquid form, warm enough to flow, in a calm enough place to last. Still, the cosmic ocean is far vaster than we once believed, quietly filling the dark in ways we are only beginning to map. Long ago, a simple experiment showed that the raw chemistry of life can arise on its own from ordinary ingredients. In the 1950s, two scientists sealed some basic gases and water in a set of glass tubes meant to mimic the young Earth and passed sparks through it to stand in for lightning. Within days, the clear liquid had turned a murky brown. When they analyzed it, they found amino acids, the same building blocks of proteins found in every living thing. They had not made life, but they had shown that the first small steps toward it can happen easily, with nothing more than common gases, water, and a spark of energy. It was a quiet revolution. It suggested that the origin of life might not require a miracle, only the right ingredients and enough time. Since then, scientists have refined and questioned the details, but the core lesson endures. The chemistry that leads toward life is not fussy or fragile. It seems to want to happen given half a chance. And if it can happen so readily in a glass tube on Earth, it may have happened in countless warm ponds and seas across the galaxy, quietly, without anyone watching. Beyond amino acids, scientists have found sugars and even the chemical letters of genetic code forming naturally in space and in fallen meteorites. In laboratory studies of certain space rocks, researchers have detected components of the molecules that store genetic information in living cells. Some of these delicate pieces appear to form in the cold reaches of space and survive the fiery fall to the ground. There is even evidence that simple sugars can assemble under conditions like those in the early solar system. Piece by piece, the list of life's building blocks found beyond Earth grows longer. It is a slow, patient accumulation of clues. None of it says that life exists elsewhere, but together, these findings paint a picture of a universe that is chemically busy, constantly cooking up the parts that life is made of, whether or not anyone is around to use them. The molecules that make you who you are may be, in some sense, a cosmic commonplace. That thought has a way of making the night sky feel less like an empty void and more like a vast and quiet kitchen, where the same familiar recipe is being prepared over and over in the dark. Comets, those icy wanderers of the outer solar system, carry a surprising richness of organic chemistry frozen inside them. When a spacecraft flew close to one comet and sampled the gas streaming off it, scientists found a whole medley of molecules, including some that on Earth are usually tied to living things. That last part came with an important lesson. One such molecule, which some had hoped might be a fingerprint of life on distant worlds, was found forming on a comet where nothing lives at all, and even drifting in the empty gas between stars. In other words, chemistry alone can make it, no biology required. This is exactly the kind of careful caution that keeps the search honest. A molecule that seems like a sign of life in one place may be made without life in another. Comets remind us to hold our excitement gently and to check every clue twice. But they also show, once more, how much complex chemistry the cosmos brews on its own. These frozen travelers are like time capsules, preserving the ingredients of the young solar system. And every so often, one passes by, trailing its ancient chemistry across the sky. There is an old and gentle idea that life, or its seeds, might travel between worlds, carried on rocks and dust across space. It is called panspermia, and it suggests that living things, or at least the chemistry that leads to them, need not begin fresh on every world. A meteorite strike on one planet can blast pieces of its surface into space, and some of those pieces, sheltering microbes or organic molecules, might eventually drift to another world and land. In this picture, life could spread slowly through a solar system, or even between the stars, seeding new worlds from old ones. It remains unproven, and it does not answer the deepest question of where life first began. It only moves the starting point. But some hardy microbes on Earth can survive the harshness of space for a surprisingly long time, which keeps the idea alive. Perhaps life on Earth arrived from elsewhere. Perhaps Earth has seeded other worlds. Or perhaps every living world lights its own spark independently. We do not know. But the thought that life might be a traveler, patient and quiet, drifting from world to world across the eons, is a soft and strangely comforting one. On one distant moon in our own solar system, a thick orange haze fills the sky, made of complex chemistry that some find tantalizing. This haze is built from molecules called tholins, formed when sunlight breaks apart simpler gases, and the fragments recombine into rich, tar-like compounds. They give the moon its warm, muted color, a soft amber glow rather than a clear blue sky. Tholins are interesting because they are the kind of complicated organic chemistry that, on Earth, sits somewhere on the long road toward life. That does not mean the moon is alive. It is far too cold for water to flow on its surface, colder than almost anywhere you can imagine. But it is a natural laboratory, running strange chemical experiments across its whole atmosphere, endlessly in the dark. Studying it helps scientists understand how complex molecules form and gather, which is part of understanding how life might begin. And there is something dreamlike about the image itself. A whole world wrapped in orange mist, its chemistry slowly churning under a distant, dim sun. As your thoughts grow soft, you can picture that gentle amber sky, hanging silent over a frozen and mysterious land. Here on Earth, life has been found thriving in places so harsh they seem impossible, which quietly widens the odds for life elsewhere. These tough survivors are called extremophiles, organisms that love conditions that would kill most living things. They live in boiling hot springs and in pools of acid. They survive being frozen solid or dried to dust or crushed under enormous pressure at the bottom of the sea. They thrive in salt so concentrated that almost nothing else can bear it. Each of these creatures teaches the same gentle lesson. Life is far more stubborn and adaptable than we once believed. If living things can flourish in Earth's most brutal corners, then the range of places that might support life on other worlds grows wider than we thought. A planet does not have to be a mild green paradise. It might be frozen or scalding or drenched in strange chemistry, and still, perhaps, hold something alive in its harshest niches. The extremophiles are a quiet source of hope in the search. They whisper that the universe may have more room for life than a comfortable world like ours would suggest, in places we might once have dismissed as hopeless. There is a tiny creature on Earth, smaller than a grain of sand, that can survive the raw vacuum of open space. It is called the tardigrade, sometimes nicknamed the water bear, a plump little animal with 8 stubby legs. When conditions turn deadly, it can pull in its limbs, expel most of its water, and curl into a dried-out husk, its life almost paused. In this state, it has endured being frozen near absolute cold, heated past boiling, blasted with radiation, and even exposed directly to the vacuum and rays of space during real experiments. Then, given a little water, it swells back up and simply carries on. If an animal this small and simple can shrug off conditions that would destroy almost anything else, it makes you wonder what life might manage on other worlds. Tardigrades are not aliens, of course. They are humble creatures living in the moss and the soil all around us. But they are living proof that life can be astonishingly tough, able to wait out disaster in a kind of gentle sleep. There is something soothing in that image, a creature so at peace with hardship that it can simply dry up, drift, and wait for better days. One kind of bacterium on Earth can withstand blasts of radiation that would kill almost any other living thing many times over. Scientists gave it a nickname that means, roughly, the toughest bacterium in the world. It can survive doses of radiation thousands of times stronger than what a person could endure, and it does so with a quiet, almost casual resilience. When the radiation shatters its genetic code into pieces, the little organism simply stitches itself back together, repairing the damage with a patience and efficiency that astonishes researchers. It can also survive extreme cold, dryness, and the vacuum of space. Its very existence stretches our idea of where life could hold on. Some worlds are bathed in far more radiation than Earth, from harsh stars or exploded neighbors, and we might assume nothing could live there. but this small survivor suggests otherwise. Life, at least in its hardiest forms, may have tricks for surviving conditions we would call impossible. It is a comforting kind of stubbornness. Somewhere in the soil beneath us, or in a laboratory dish, this tiny creature is quietly repairing itself again and again, refusing to give up. A small emblem of how tenacious life can be. Deep on the ocean floor, in total darkness, whole ecosystems thrive without a single ray of sunlight. Along cracks in the seabed, hot water rich in minerals gushes up from within the earth, forming tall chimneys called hydrothermal vents. Around them, in water that never sees the sun, life flourishes in astonishing abundance. Tube worms taller than a person sway in the currents. Ghostly crabs and shrimp crowd the rocks. And at the base of it all are microbes that do something remarkable. Instead of drawing energy from sunlight, as plants do, they draw it from the chemicals in the vent water itself. This process, living on chemistry rather than light, changed how scientists think about where life can exist. A world does not need a bright sun and a green surface. It might hold life in the dark, around vents on the floor of a hidden ocean, fed entirely by the warmth and chemistry rising from below. That possibility opens up whole new kinds of worlds to consider. And it means that when we search for life, we should not only look toward the light. Some of it may be waiting in the deepest, quietest dark. Because of those deep-sea communities, we now know that life does not always need sunlight to survive. For a long time, it seemed obvious that sunlight was the foundation of all life. Plants catch it, animals eat the plants, and the whole web hangs from that single bright thread. But the creatures around the deep-sea vents live in permanent darkness, sustained by the Earth's own inner heat and chemistry. Their entire world runs on a different kind of fuel. This matters enormously for the search beyond Earth. It means that a frozen moon, its surface sealed under miles of ice, cut off from any sun, could still, in theory, hold a warm, dark ocean full of life below. Energy could come from within, from the slow flexing and heating of the moon's interior, rather than from a distant star. Suddenly, the number of places worth considering grows. Not just sunny worlds in comfortable orbits, but hidden seas beneath frozen shells, far from any warmth we could see. Life may not always reach toward the light. Sometimes, perhaps, it gathers quietly in the dark, warmed from below, in oceans no sunbeam has ever touched. Far below the ground beneath your feet, life exists inside solid rock, in a hidden world we have only recently begun to explore. When scientists drill deep into the Earth's crust, they keep finding microbes living in the tiny pores and cracks of the rock, kilometers down. These organisms live incredibly slow lives, some perhaps dividing only once in thousands of years, sipping energy from the chemistry of the stone around them. This buried world is sometimes called the deep biosphere, and it may hold an enormous amount of life, quietly out of sight. The discovery reshapes our sense of where living things can dwell. Life is not only spread across the surface of our world, it soaks down into the rock itself, filling the dark spaces underground. If life can persist so deep within Earth, then perhaps it could survive beneath the surface of other worlds too, sheltered from harsh radiation and cold by the rock overhead. A planet that looks dead on the outside might, conceivably, harbor a slow and silent biosphere far below. It is a strange, calm thought. Beneath everything solid and still, life may be quietly present, keeping its own slow time in the dark. Life on Earth has been found in acid, in extreme salt, in boiling water, and locked in ancient ice, adapting to nearly every hardship. There are microbes that live happily in water as acidic as battery fluid. Others thrive in pools so salty that the water shimmers with crystals. Some make their home in the scalding runoff of hot springs, where the water is near boiling. Others have been revived from ice that kept them frozen for tens of thousands of years. In every direction that seems too extreme for life, some organism has found a way to make a living there. This astonishing range is one of the strongest reasons scientists keep an open mind about life elsewhere. If life on our single planet has spread into so many punishing corners, then the conditions that might support living things across the galaxy are far broader than a gentle, Earth-like world alone. The universe is full of harsh places, and once we might have crossed them all off the list. But Earth's own extremophiles keep telling us not to be so quick. Life, it seems, is endlessly inventive, endlessly patient, and endlessly willing to make a home where none should be possible. All of these hardy survivors point toward a single, quiet possibility. Life may not need conditions exactly like ours in order to exist. We naturally imagine alien life on worlds resembling Earth, with mild temperatures, breathable air, and gentle seas. That is understandable since Earth is the only living world we know. But the more we learn about life's toughness, the more that assumption loosens. Living things here endure cold, heat, pressure, darkness, radiation, and drought. They live without sunlight, deep in rock, at the bottom of the sea. So the range of worlds that might hold life could be much wider than a simple twin of Earth. A frozen moon, a hazy planet, a world around a dim red star. All of these might, in principle, host something alive in some niche we have not thought to consider. This does not make life common. It only makes the search broader and more humble. We should look not just for worlds like ours, but for worlds where life, in its stubborn creativity, might have found a foothold. The living universe, if it exists, may wear many strange and unfamiliar faces. Some scientists gently wonder whether life elsewhere might be built on a different chemistry than our own. Every living thing on Earth is based on carbon, a wonderfully flexible element that links easily into the long chains that life requires. It is hard to imagine a better foundation, and carbon is common throughout the cosmos, so life elsewhere may well share it. But researchers have played with other ideas, just to test the edges of possibility. Could a different element, such as silicon, form the backbone of some exotic life? Silicon sits just below carbon in the chemical charts and can also form chains, though far less readily. Most scientists think carbon is still by far the most likely basis for life anywhere. Yet the question is worth asking because it keeps our imaginations honest. We should not assume that all life must be a close copy of what we know. It might use different building blocks, different chemistry, in ways we can barely picture. This is not a claim that such life exists. It is only a gentle openness, a willingness to admit that the living universe might be stranger in its deep chemistry than anything we have yet seen. Life might also, in theory, use a different liquid than water as the stage for its chemistry. Water is a marvelous solvent, the medium in which the chemistry of earthly life takes place, and it is common in the cosmos, so it is a natural first thing to look for. But on very cold worlds, water freezes hard as rock and cannot flow. On such worlds, other liquids might take its place. On one frigid moon in our own solar system, lakes and rivers of liquid methane and ethane flow across the surface, fed by a slow chemical cycle much like our water cycle, only far colder. Some scientists have wondered, cautiously, whether an utterly different kind of life could ever use such a liquid as its medium instead of water. It is a deeply speculative idea, and there is no evidence for it. Most researchers still expect that if life exists nearby, water will be involved. But the thought stretches the mind pleasantly. Perhaps somewhere, in a cold and distant place, life flows through a liquid we would never drink, under a sky we would not recognize. We do not know, but the not knowing is part of the wonder. There is even a quiet suggestion that unfamiliar life could exist on Earth itself, unnoticed, right under our study. Some scientists have raised the idea of a shadow biosphere, a hypothetical form of life so different from the familiar kind that our usual tools might simply miss it. All the life we have ever studied shares the same basic biochemistry, which is strong evidence that it all descends from a single common origin. But could there be another, separate kind of microbial life, using slightly different chemistry, hiding in some overlooked niche? Almost certainly, we would not have detected it, because our tests are designed to find life like our own. This remains an untested idea, more a thought experiment than a discovery, and no such shadow life has been found. Yet it carries a humbling point. When searching for life on other worlds, we must be careful not to look only for exact copies of ourselves. Alien life might be subtle, unfamiliar, easy to overlook. We might even walk past strange life without recognizing it. The lesson is gentle openness, a reminder to keep our definitions loose and our eyes and our minds quietly wide. We do not have to leave our own solar system to search for signs of life, because our neighbor Mars was once a far wetter world. Today, Mars is a cold, dry desert, its surface rusted red and swept by thin winds. But the rovers and orbiters we have sent there tell a different story about its distant past. Ancient riverbeds wind across its surface. Old lake basins sit where water once pooled. Minerals that only form in water lie scattered in the soil. Billions of years ago, Mars appears to have had flowing rivers, standing lakes, perhaps even a shallow sea under a thicker atmosphere and a warmer sky. If Mars was once warm and wet, then it may once have been a place where life could begin, back when it was young. Whether it ever did, we do not yet know. But that is a large part of why we keep sending machines to dig and sample and search. Somewhere in the Martian rock may lie the faint record of a wetter, gentler age, and perhaps, just perhaps, the traces of something that once lived. It is a patient search carried out slowly by robots working alone on a quiet red world. On Mars, scientists have detected faint traces of a gas that, on Earth, is often linked to life, though the mystery remains unsolved. The gas is methane, and its presence in the thin Martian air has puzzled researchers for years. On Earth, much of the methane in our atmosphere is produced by living things, but methane can also be made by ordinary geological processes with no life involved at all, so its presence on Mars is a clue, not an answer. What makes the Martian case especially strange is that the readings seem to come and go. Some measurements find whiffs of it, others find almost none, and the levels appear to change with time and place in ways that are hard to explain. Scientists are still working to understand what is happening. It may be geology, slowly releasing gas trapped in the rock. It may be something else. The honest position is that we do not yet know the source. It is one of those open, unfinished questions that make Mars so compelling. A faint, flickering trace of gas drifting through a cold red sky, keeping its secret for now. Decades ago, a meteorite from Mars sparked a famous debate about whether it held signs of ancient microbial life. The rock had been blasted off the surface of Mars long ago, wandered through space, and eventually fallen to Earth, where it was found in the ice of Antarctica. When scientists examined it closely, they saw tiny structures that some thought resembled fossilized microbes, along with certain minerals and chemistry that hinted at biology. The announcement caused a sensation. But other researchers looked at the same features and argued they could have formed without any life at all, through ordinary chemical and physical processes. Over the years, the case for ancient Martian life in that particular rock weakened, and today, most scientists are not convinced it holds real fossils. Yet the debate was not a failure. It sharpened the questions, forced everyone to think hard about how you would even recognize alien life, and helped launch a new era of searching. It was a reminder that extraordinary claims need extraordinary evidence, and that careful doubt is a form of respect for the truth. The mystery of that little rock helped teach us how to look. One of the most promising places to search for life is not a planet at all, but a moon with a vast ocean hidden beneath its ice. This moon, circling the giant planet Jupiter, is wrapped in a shell of ice, and beneath that frozen crust lies a global ocean of liquid water, kept warm by the constant flexing of the moon as it orbits. That ocean may hold more water than all the seas of Earth combined, sealed away in the dark beneath the ice. Where there is liquid water, warmth, and the right chemistry, scientists cannot help but wonder about life. No sunlight reaches that buried sea, but as we have seen, life on Earth can thrive in darkness, fed by heat and chemistry from below. Could something be swimming or drifting in that hidden alien ocean? We do not know, and we may not know for a long time. But it is one of the great questions of our own cosmic backyard. A quiet, frozen moon, holding a secret sea, turning slowly around its enormous planet, keeping whatever it holds locked safely away in the cold and the dark. That icy moon may occasionally spray its hidden ocean out into space, offering a way to sample it without ever landing. Telescopes and spacecraft have seen hints of plumes, tall fountains of water vapor, rising from the moon's frozen surface. If these plumes come from the ocean below, breaking through cracks in the ice, then they carry a little of that hidden sea up into space, where a passing spacecraft could fly through and taste it. This is a thrilling prospect for scientists. Instead of drilling through miles of ice, a difficult and distant dream, we might simply catch the ocean as it sprays outward and study whatever it contains. Future missions are being designed to explore this moon in detail, to map its ice and sniff its plumes and search for the chemistry of life. It will take time and patience and long travels across the solar system. But the idea is wonderful in its simplicity. A frozen world quietly breathing out its ocean, and us, far away, hoping to catch a whisper of what lies beneath. As you rest, you can picture those silent fountains of ice glittering as they rise. Around the ringed planet Saturn, another small moon shoots great geysers of water into space, and they carry the ingredients of life. This little moon is bright and icy, and near its southern pole, huge jets of water vapor and ice particles erupt continuously from cracks in the surface. Spacecraft have flown directly through these plumes and analyzed them, and what they found was remarkable. The spray contains not only water, but also salts and organic molecules, and signs of warm chemistry happening in the ocean below. In other words, this tiny moon has liquid water, a source of energy, and the chemical building blocks, three of the things life as we know it seems to need, all in one small, frozen package. That does not mean life is there, but it means the conditions are surprisingly welcoming in a place no one would have guessed. A small, icy moon far from the sun, quietly venting a habitable recipe into space. It is one of the most exciting discoveries in the whole search, and it happened almost by accident, as a spacecraft passed through a glittering plume and looked closely at what it caught. On another of Saturn's moons, rain falls, rivers flow, and lakes shimmer, but they are not made of water. This strange and beautiful world is the only place besides Earth where we know that stable liquid pools sit on the surface. But here, in the deep cold, the liquid is not water. It is methane and ethane, gases on Earth, kept liquid by the intense cold of this distant moon. There are lakes and seas of it near the poles, fed by methane rain from an orange, hazy sky, flowing through channels carved into the icy ground. It is an eerily familiar landscape, built from utterly unfamiliar materials. A world with weather and rivers and shorelines, all running on a different chemistry than ours. Beneath its surface, this moon may also hide an ocean of ordinary water. Scientists find it fascinating for many reasons, including the faint, speculative question of whether any kind of life, perhaps very different from ours, could exist in such a place. We do not know. But as a piece of scenery for the sleeping mind, it is hard to beat. Gentle methane rain falling softly through amber mist onto quiet alien seas. That same hazy moon is like a natural chemistry laboratory, running experiments that may echo the early steps toward life. Its thick atmosphere is rich in the kinds of molecules that, given energy, can build up into more complex organic compounds. Sunlight and other energy break apart the simple gases high in its sky, and the pieces recombine into a rain of complicated chemistry that drifts down and coats the surface. Some scientists study this moon precisely because it may resemble, in certain ways, the conditions on the young Earth before life began, only frozen in a kind of chemical slow motion. By understanding what happens there, we may learn something about how the chemistry of life first gets started. It is far too cold for that chemistry to come alive as it did here, most researchers believe. But it is a place where the early chapters of life's story may be written out over and over in the cold without ever reaching the living page. A whole world quietly practicing the chemistry of beginnings under its orange sky, teaching us about our own distant origins. Even our scorching neighbor Venus became, for a time, the center of a careful debate about the possibility of life in its clouds. Venus is a hellish place at the surface, hot enough to melt lead, crushed under a thick, choking atmosphere. No one expects life on that ground. But high above, in the cloud layers, the temperatures and pressures are far milder, almost gentle by comparison. A few years ago, scientists reported detecting a certain gas in those clouds that, on Earth, is often associated with life. The findings set off a wave of excitement and quickly a wave of careful scrutiny. Other researchers questioned whether the gas was really there at all, or whether it had been misread. The debate continues, unresolved, with measurements argued back and forth. The honest summary is that we do not know what, if anything, it means. It may be a mistake. It may be unusual chemistry. It is almost certainly not proof of life, but it reminded everyone that even a world we had written off might hold surprises, and that the search for life sometimes turns up in the last place you would look, drifting in the clouds of a burning planet. Whatever the truth about that gas, the clouds of Venus remain a strange and thought-provoking place. 50 or so kilometers above the deadly surface, there is a layer where conditions are far less extreme, where the temperature would be almost bearable and the pressure close to that at Earth's surface. Some scientists have wondered, very cautiously, whether microbial life could ever drift there, floating in the hazy air, never touching the scorching ground far below. It is a highly speculative idea, with no solid evidence behind it, and the clouds hold their own harsh challenges, being made largely of acid. Most researchers are doubtful, but the mere fact that people take the question seriously shows how the search for life has expanded. We now consider oceans under ice, chemistry in orange haze, and the possibility of life adrift in the sky of a furnace world. None of these are confirmed. All of them are simply places worth a careful look. The universe keeps offering us strange rooms to peer into, and Venus, our brilliant evening star, turns out to hold more mystery in its clouds than its beautiful, distant glow would ever suggest. Between Mars and Jupiter, a small round world in the asteroid belt turned out to be far more interesting than a mere lump of rock. This little world, the largest object in the asteroid belt, was long thought to be a dead and battered survivor of the early solar system. But when a spacecraft settled into orbit around it and looked closely, it found bright patches on the surface that turned out to be salts, left behind by briny water that had risen from below and evaporated. That means this small world once held, and may still hold, pockets of liquid water beneath its surface, mixed with salts and other chemistry. It is not a place anyone expects to find life, but it joins a growing list of small, cold worlds that hold more water and more activity than we ever imagined. The old picture of the solar system, a few living or dead planets and a scattering of inert rocks, keeps giving way to something richer. Even a modest world in the asteroid belt has its hidden brine, its quiet chemistry, its slow secrets. The more we look, the more the solar system reveals itself as a place of water and possibility, tucked into the most unexpected corners. One of the great surprises of modern exploration is that hidden oceans, sealed beneath ice, may be common in the outer solar system. For most of history, we pictured oceans as things that lie open beneath the sky, as they do on Earth. But out among the giant planets, several moons appear to hold vast seas of liquid water, locked deep below frozen shells. There is the ocean moon of Jupiter, and the little geyser moon of Saturn, and there are hints of buried water on several others besides. These worlds stay warm enough inside through the slow flexing of tides and the heat of their own interiors to keep water liquid far from the sun. It is a quiet revolution in how we see our neighborhood. The solar system may hold many more oceans than we once believed, most of them hidden, dark, and sealed away. And where there is a stable ocean, warmth, and chemistry, the question of life is never far behind. We may live in a solar system dotted with secret seas, each one turning slowly in the cold, each one keeping its own long counsel beneath the ice. In fact, when you count the hidden oceans, worlds with water below the surface may outnumber those with water on top. Earth wears its ocean openly, under an open sky warmed by the nearby sun. That kind of surface sea may actually be the rarer arrangement. Out in the cold reaches, water survives more easily when it is tucked beneath a protective layer of ice, insulated from the freezing vacuum above. So the typical ocean world across the galaxy might not look like Earth at all. It might look like a frozen ball, gray and quiet on the outside, with all its water hidden deep within. This changes how we think about the search for life. Perhaps we should not only seek blue planets with open seas, but also frozen worlds that hide their oceans below. Life, if it dwells in such places, would live in perpetual darkness, sealed off from the stars, unaware of any sky. It is a humbling thought that the most common home for life might be one where no one ever sees the sun. The universe may keep most of its oceans and most of its secrets quietly out of sight. Scientists dream of bringing pieces of Mars back to Earth so they can search for signs of ancient life with their most powerful instruments. A rover is now gathering carefully chosen samples of Martian rock and soil, sealing them into tubes and setting them aside on the surface. The hope is that a future mission might one day collect those tubes and carry them home across the vastness of space. Here on Earth, in laboratories far more sensitive than anything we could send to Mars, scientists could examine them for the faintest chemical whispers of past life. It is an enormous challenge, requiring feats of engineering that push the limits of what we can do. But the payoff could be historic. A single Martian rock studied in an earthly lab might finally tell us whether life ever stirred on that other world in its warmer, wetter youth. For now, those precious samples wait on the Martian surface, sealed and patient, resting in the thin, cold air of a distant planet. And somewhere in them, perhaps, lies an answer that has been waiting billions of years for someone to come and read it. So far, in all our searching of the solar system, we have found no confirmed life beyond Earth, and even that is a meaningful result. It might sound disappointing, but it is not. Every world we examine and find lifeless still teaches us something, narrowing the possibilities, sharpening our questions. And the search has barely begun. We have only sampled a few worlds, and only their surfaces, and only in a handful of places. The hidden oceans remain unexplored. The deep rock of other worlds is untouched. Vast possibilities are still completely unexamined. So the quiet answer, for now, is simply this. We have not found life elsewhere yet, and we have not looked in most of the places where it might be. That is not a closed door. It is an open one, leading into rooms we have not yet entered. The absence of an answer is not the same as the answer being no. It is the honest, patient state of a search that is still young. And there is a certain peace in that, in knowing the question is still alive, still open, still waiting gently for us out there in the dark. Since we cannot yet visit other stars, one way to search for life is simply to listen for it. This idea gave rise to a field of science devoted to scanning the skies for signals from other civilizations, often known by the initials SETI, the search for extraterrestrial intelligence. The reasoning is elegant. If an advanced civilization exists somewhere out there, it might send out radio signals, either on purpose or as the natural leakage of its technology, much as our own radio and television broadcasts spill quietly into space. By pointing sensitive radio telescopes at the stars and listening carefully, we might catch such a signal, a whisper of another mind across the void. It is a patient, humble kind of search, mostly long stretches of silence, sifting through natural noise. But its very existence is moving. Somewhere on Earth, telescopes are turned outward, quietly listening, just in case. In all the noise of the cosmos, they wait for a pattern that could only come from someone like us. As you settle deeper toward sleep, you can imagine those great dishes tilted toward the stars, holding still, listening to the dark on our behalf. The first real attempt to listen for signals from another star took place more than 60 years ago, with a single dish and a lot of hope. In 1960, an astronomer named Frank Drake, the same one who later wrote the famous equation, pointed a radio telescope toward two nearby stars. He called it Project Ozma, after the land of Oz, a fitting name for a search into the unknown. For a few weeks, he listened, hoping to catch some artificial signal drifting in from those distant suns. He heard nothing conclusive, only the ordinary crackle of the cosmos, and, at one point, a false alarm that turned out to be from Earth. But it did not matter that the search came up empty. What mattered was that it happened at all. For the first time, a human being had seriously turned an instrument toward the stars and asked, quietly, "Is anyone there?" That simple act opened a door that has never closed. The listening he began still goes on today, with far greater tools, across far more of the sky. It all traces back to those first patient weeks, one man and one dish, listening into the silence. Radio waves turn out to be a natural choice for anyone trying to send a signal across the galaxy. Of all the ways to communicate across immense distances, radio has some real advantages. Radio waves travel at the speed of light. They can cross vast stretches of space without being blocked by gas and dust, and they are relatively cheap and easy to produce for any civilization with technology. So if others are out there and wish to be heard, or if their machines simply leak signals as ours do, radio is a very reasonable band to broadcast on. That is why so much of the search has focused on radio. It is a shared logic that we hope any technological civilization might arrive at, a kind of common ground written into physics itself. There are other possibilities too, which we will drift toward shortly, but radio remains a sensible first place to listen. It is a quietly hopeful idea that the laws of nature might give distant minds a shared channel, a frequency where, in principle, we could find one another. And so the great dishes listened to the radio sky, tuned to the physics we all must share, waiting for a voice. Within the radio spectrum, there is a particularly quiet band that scientists nicknamed the water hole, thought to be a natural place to listen. In this stretch of frequencies, the natural static of the galaxy is especially low, making it easier to pick out a faint artificial signal against the background hush. The name comes from the two chemical fragments whose natural signals sit at the edges of this band, and together, those fragments spell out water. Scientists poetically imagined it as a cosmic watering hole, a calm and natural gathering place where different civilizations, all facing the same physics, might come to listen and be heard. It is a lovely idea, whether or not nature actually cooperates. The thought that there might be a shared quiet channel, a peaceful clearing in the noise of the cosmos where distant minds could meet, gives the search a gentle poetry. Much of the listening has focused there, in that calm band, in case anyone else has had the same idea. As you drift, you can picture it as a still pond in a noisy forest, where creatures come quietly to drink, and where, perhaps, someday, we might hear another arrive. Once, in 1977, a radio telescope caught a strong, strange signal that has never been explained or seen again. An astronomer reviewing the data from a telescope's overnight scan noticed a burst of radio energy so striking that he circled it on the printout and wrote a single word beside it, an expression of surprise. That signal, now famous, lasted a little over a minute and stood far above the usual background noise. It had many of the qualities you might expect from an artificial signal from deep space, coming from the direction of a distant patch of sky. And then it was gone. Despite many attempts over the years to find it again, listening to the same spot in the sky, it has never returned. Scientists still do not fully agree on what caused it. Various natural explanations have been offered, and some remain plausible, but none has been confirmed. It sits in the record as a genuine mystery, a single, unrepeated whisper from the dark. It is probably not a message from another world, but we cannot be sure, and that small uncertainty is part of what makes it linger so hauntingly in the mind. Part of what makes that famous signal so tantalizing is precisely that it never happened again. In science, a result that cannot be repeated is difficult to trust. If the signal had truly come from a distant civilization, we might have expected it to recur, to be steady, to be found again when we looked back. Instead, it appeared once and vanished, leaving only that single circled printout behind. This is why most scientists are cautious about it. A one-time event could have many causes, some of them quite ordinary, and without a repeat, it is nearly impossible to study. And yet, the not knowing is exactly what keeps it alive in our imaginations. It was strong. It was strange. It looked like the kind of signal we hoped to find. And then it slipped away forever. It hovers in that uncertain space between a natural fluke and something more, never quite resolved. Perhaps one day we will understand it fully. Perhaps we never will. For now, it remains a gentle ghost in the story of the search, a reminder of how much we still do not know, and of how the universe sometimes speaks just once and then falls silent again. We have not only listened for messages, on a few occasions we have sent them, including one beamed toward a distant cluster of stars. In 1974, scientists used a giant radio telescope to broadcast a short, carefully designed message out into space, aimed at a dense group of stars far away. The message was a simple pattern of radio pulses that, when arranged correctly, formed a picture. It included basic facts about us, such as the numbers we count with, the chemistry of our life, a rough figure of a human being, and a sketch of our solar system. It was more a symbolic gesture than a real attempt at conversation, since the target is so far away that any reply, if one ever came, would take many thousands of years to arrive. But it was a milestone all the same. The first time humanity deliberately called out into the cosmic dark with a structured message. That small pattern of radio waves is still traveling outward now, crossing the emptiness at the speed of light, a quiet postcard from Earth, sailing toward stars we will never reach, carrying a simple hello into the future. The search for signals continues today, on a scale far larger than the early pioneers could have dreamed. Modern efforts use some of the world's most powerful radio telescopes to scan enormous numbers of stars across broad ranges of frequency, sifting through mountains of data with the help of computers. Where Frank Drake once listened to 2 stars for a few weeks, today's programs survey many thousands, looking for any hint of an artificial signal hiding in the noise. It is a vast and patient undertaking, funded and carried out by dedicated scientists who know they may listen for a lifetime and hear nothing. And yet they listen because the question matters, and because the only way to find a signal is to keep looking for one. So far, no confirmed message from another civilization has ever been found. The sky, to our ears, remains silent. But we have searched only a tiny fraction of it, at only some frequencies, for only a short time. The silence so far is not an answer. It is simply how far we have gotten in an enormous task. And somewhere tonight, the great dishes are still turning, still listening, still hoping. Beyond radio, scientists have realized that an advanced civilization might reveal itself in other ways, through what are called technosignatures. A technosignature is any sign of technology that we might detect from afar. It could be a powerful laser flashing across space, used for communication or other purposes. It could be unusual gases in a planet's atmosphere, the kind that industry might produce. It could even be the faint heat or light of enormous structures built around a star. The idea broadens the search well beyond listening for radio. Instead of only waiting for a deliberate message, we might catch the accidental fingerprints of a technological society going about its business, whatever that business might be. Of course, we have found no such signs, and each idea comes with great uncertainty. But the concept is powerful. A civilization need not be trying to talk to us for us to notice it. Its very existence, its lights and machines and industry, might leave marks on the cosmos that a careful observer could spot. It is another way of keeping our eyes open, another set of clues to watch for as we scan the distant worlds for any hint that we are not alone. One scientist imagined a way to rank civilizations by how much energy they can harness, a scale that stretches the mind. In this idea, a civilization might first learn to use all the energy available on its home planet. Later, it might capture the full energy of its star. Later still, in the most extreme vision, it might command the energy of an entire galaxy. These stages form a kind of ladder of imagined progress, from planet to star to galaxy. By this measure, we humans have not even reached the first rung. We use only a small fraction of the energy our own planet offers. The scale is entirely hypothetical, a thought experiment rather than a description of anything real. No such advanced civilizations are known to exist, but it is a useful way to picture just how far a very old, very advanced society might go, and how modest our own achievements still are by comparison. It invites a certain humility. If others are out there, some might be almost unimaginably beyond us, wielding energies we can barely conceive. Or perhaps no one ever climbs that ladder at all. We simply do not know, and the not knowing is vast. One imagined technology has captured people's minds for decades, a giant structure built to capture the energy of a star. The idea is that a very advanced civilization, hungry for energy, might surround its sun with a vast array of collectors, gathering a huge portion of the star's light. Such a structure would be enormous beyond easy imagining, and it would change how the star appeared from far away. Instead of shining normally, the star might seem dimmed or oddly colored, glowing strangely in the infrared as the captured energy was used and released as heat. This means that, in principle, we might detect such a megastructure from a great distance by noticing a star that behaves in an unusual way. It remains purely hypothetical, a concept with no evidence behind it, and no such structure has ever been found. But it gives astronomers one more thing to watch for, one more possible sign of a civilization far beyond our own. It is a grand and slightly eerie thought, a star wrapped in the works of some ancient mind, its light quietly harvested, shining out across the galaxy in a way that hints at a builder we will likely never meet. A few years ago, one particular star behaved so strangely that some briefly wondered whether we had found such a structure. This distant star was seen to dim in sudden, irregular ways, its light dropping by large amounts and then recovering in a pattern quite unlike an ordinary planet passing in front of it. The oddity was striking enough that a handful of scientists and a great many excited onlookers raised the possibility that something enormous, perhaps even artificial, was blocking the light. For a while, the star was the talk of the astronomy world, but as researchers studied it more carefully, a more ordinary explanation emerged. The dimming is now generally thought to be caused by clouds of dust orbiting the star, blocking its light unevenly as they pass. It seems there was no megastructure after all, only nature being a little peculiar. And yet, the episode was valuable. It showed how seriously scientists will investigate an anomaly and how carefully they weigh the evidence before leaping to grand conclusions. Most mysteries, in the end, turn out to have natural answers, but we do not know that until we look, and looking closely is exactly what good science does. After all this searching, the great puzzle remains. We have heard only silence, and there are many gentle ways to explain it. Perhaps intelligent life is simply very rare, and the nearest neighbors are too far away to hear. Perhaps civilizations tend to be short-lived, flickering into being and fading before they can be found. Perhaps others are out there but are quiet, listening rather than broadcasting, just as we mostly do. Perhaps we have not searched long enough, or in the right way, or at the right frequencies. Perhaps signals are passing through the room around you right now, and we simply lack the means to notice them. Or perhaps, for reasons we cannot guess, the galaxy really is quiet. Each of these explanations is possible, and none can yet be ruled out. The silence is real, but its meaning is unknown. It might be the silence of an empty cosmos, or the silence of a crowded one that has not yet spoken to us. This is one of the deepest open questions we have, and it has no answer tonight. So let it rest, unanswered, as so many good questions do, softly, in the quiet of your darkening room. Even though we listen, we have also sent physical messages into space, tucked aboard spacecraft now leaving the solar system. 2 spacecraft launched in the 1970s after touring the outer planets are now sailing outward into interstellar space, farther from home than anything else we have ever made. Aboard each one rides a special record, a golden disc carrying sounds and images of Earth. There are greetings spoken in many languages, music from around the world, the sounds of nature, and pictures of life on our planet. The idea was that if, in some unimaginably distant future, another civilization ever found one of these craft drifting through space, they might play the record and learn a little about the world that sent it. The chances of that are almost impossibly small. Space is vast and the craft are tiny, and they will not come near another star for a very long time. But the gesture is deeply human. We sent a message in a bottle out into the cosmic ocean, not expecting a reply, simply wishing to say that we were here. Those golden records are still out there now, carrying our quiet hello into the endless dark. On those same distant spacecraft, there is also a simple engraved plaque meant to show any finder where we are and who we are. The plaque, etched in metal, carries a set of symbols designed to be understood by a mind that shares nothing of our language or culture. It shows the figures of a man and a woman, a map pointing back toward our sun using distant landmarks in the galaxy, and a diagram of our solar system with the spacecraft's path marked leaving from the third planet. The hope was that these symbols, based on the shared logic of science and mathematics, might be readable by any intelligent finder, whoever and whenever they might be. It is a strange and touching thing to have done, to carefully design a message for a reader who may never exist, and who, if they do, we will never meet. The plaque is a portrait of humanity, stripped down to its simplest terms, sailing outward through the ages. Long after everyone alive today is gone, long after much of what we know is forgotten, that little metal card will still be out there, quietly carrying the memory of Earth into the deep. Those two spacecraft have now crossed the invisible boundary where the sun's influence fades and entered true interstellar space. It took them decades to get there, traveling outward at tremendous speed the whole time. Eventually, they passed beyond the great bubble of particles that streams out from the sun, into the region between the stars, becoming the first human-made objects ever to do so. They still send back faint signals, growing weaker each year, whispers from the very edge of our reach. In time, those signals will fade to nothing, and the craft will fall silent, coasting on in the dark. But they will not stop. With nothing to slow them, they will drift onward for millions of years, carrying their golden records and their engraved plaques through the galaxy long after they have gone quiet. It is a humbling thing to consider. We have already sent pieces of ourselves beyond the solar system, small and silent, wandering among the stars. They are out there right now, farther than the mind easily follows, carrying a little of Earth into a future so distant we can barely imagine it. And they will keep going, patient and unhurried, through the long night between the suns. There is an ongoing, gentle debate about whether we should actively send messages to the stars or simply listen quietly. Some people feel we should announce ourselves boldly, broadcasting powerful signals to let any neighbors know we are here, in the hope of making contact. Others urge caution, arguing that we know nothing about who might be listening, and that it may be wiser to stay quiet until we understand more. This debate has no easy resolution because it touches on hopes and fears that reach beyond what we can measure. We cannot know whether reaching out would bring friendship, indifference, or something to be wary of, since we have no example of another civilization to learn from. So far, we have mostly listened, sending only a handful of deliberate messages. The larger question of whether to shout or to whisper remains open, discussed thoughtfully by scientists and thinkers who take it seriously. It is one of those rare questions where our choices as a whole species might matter, and where reasonable people disagree. For tonight, there is nothing to decide. It is simply interesting to know that somewhere, quietly, people are weighing whether and how we should say hello to the universe. In recent years, something remarkable happened. For the first time, we detected objects passing through our solar system that came from another star entirely. Until then, everything we had ever observed in our cosmic neighborhood had been born here, part of our own sun's family. But then astronomers spotted a small object moving far too fast, on a path too steep to have come from around our sun. It was a visitor from interstellar space, a piece of some other star system just passing through. The discovery was thrilling. It meant that material from distant stars does reach us, drifting across the immense gulf between the suns, and that we now had the tools to notice it. Such objects do not stay. They sweep in, round the sun, and head back out into the dark, never to return. But for a brief while, we could study a genuine fragment of another world, delivered to our doorstep by chance. It was a reminder that the solar system is not sealed off from the rest of the galaxy. Now and then, a traveler arrives from far away, lingers for a moment in our skies, and moves on. The first of these interstellar visitors, spotted in 2017, was strange enough to spark years of discussion. It was small and elongated, and it behaved in a few ways that puzzled astronomers, tumbling oddly as it moved and shifting its speed slightly in a manner not fully explained at first. Because it was discovered on its way out, already leaving, there was only a short window to observe it, and it was too faint and far to see in detail. Most scientists concluded it was a natural object, perhaps an unusual comet or a fragment of rock and ice from another system. Its odd behavior explained by ordinary, if uncommon, processes. A small number wondered aloud whether anything about it might be artificial, though this remained very much a minority view without solid support. In the end, we simply did not get enough data to answer every question before it slipped away. It remains a slightly mysterious first, an unusual traveler that came and went before we could fully understand it. But its greater importance was clear. It proved that interstellar visitors were real and that we could catch them, opening a new window on the galaxy beyond. 2 years later, a second interstellar visitor arrived, and this one looked much more familiar. Discovered in 2019, it was clearly a comet, with a fuzzy, glowing cloud of gas and dust around it, just like the comets born in our own solar system. But its path showed that it too had come from beyond our sun, another wanderer from the deep. Because it was spotted on its way in, scientists had more time to study it, and they found that it was, in most respects, reassuringly ordinary, a comet much like our own, only from somewhere else. That was a fascinating result in its own right. It suggested that other star systems make comets from similar materials to ours, that the chemistry of the galaxy is, in some ways, shared. 2 interstellar visitors, so close together in time, told astronomers that such objects are probably passing through all the time, and that we had simply not been able to see them before. The galaxy, it seems, is quietly exchanging pieces of itself, sending fragments of distant systems drifting across the void, some of them sweeping, now and then, right through our own small corner of space. Then, in 2025, a third interstellar visitor appeared, and it turned out to be one of the most interesting yet. It was discovered by a survey telescope watching the skies, and its path quickly revealed that it, like the others, had come from beyond our solar system. Careful study showed it to be a comet, a natural object of ice and dust, streaming out gas as it neared the sun, just as comets do. The official view, supported by the major space agencies and most astronomers, is straightforward. It is a natural comet, the third confirmed interstellar object, following the 2 that came before. It swept in toward the sun, rounded it, and is now heading back out into the dark, never to return. As with the earlier visitor, a few voices speculated about more exotic possibilities, but the evidence points clearly to a comet. What made it special was the chance to study a fresh sample of another star system in more detail than ever before, using our best telescopes. Each such visitor is a small gift from the galaxy, a piece of somewhere else, arriving briefly in our skies before continuing on its long, lonely journey through the stars. Astonishingly, that third visitor may be far older than the sun itself, a relic from the early days of our galaxy. When scientists studied its motion and traced where it likely came from, some concluded that it may have formed billions of years before our own solar system existed. By one estimate, it could be around 7 billion years old, drifting through the galaxy for eons, older than the sun, older than the Earth, older than nearly anything we can point to. If that is right, then this small comet is a frozen fragment of an ancient time, made when the galaxy was young and only now passing briefly through our neighborhood. Think of the patience of that long crossing. For billions of years, it wandered the dark between the stars, untouched and unseen, until, for a few short months, it crossed our small pool of sunlight, was noticed by us, studied, and then continued on its way. It carried within it the chemistry of a far older era, a message not from a civilization, but from the deep past of the galaxy itself. And soon it will be gone again, back into the long dark, carrying its ancient secrets onward through time. These interstellar visitors hint that such travelers may be common, and that we will soon find many more. If 3 of them passed through in the space of a decade, once we had learned to look, then space must be full of them, mostly slipping by unseen. Each star, over its long life, likely casts off fragments of rock and ice, and those fragments drift across the galaxy for ages, occasionally crossing paths with other systems. New telescopes, more powerful and watchful than any before, are coming into service, and they are expected to find these interstellar wanderers far more often, perhaps many each year. That means the coming years may bring a steady stream of visitors from other stars, each one a small sample of a distant system delivered to us for study. It is a wonderful prospect. Without ever leaving home, we may be able to examine pieces of many other star systems, learning what they are made of and how they formed. The galaxy, it turns out, is not a collection of isolated islands, but a place where material drifts and mingles, where fragments of far-off worlds occasionally arrive at our shore. And we are just now learning how to greet them. Now we come to a subject that has drawn a great deal of attention lately here on Earth: the mystery of strange objects in our own skies. In recent years, governments and militaries have begun to speak more openly about unexplained things seen in the air, objects that pilots and instruments have detected but could not immediately identify. The modern term for these is unidentified anomalous phenomena, a careful, neutral phrase chosen to avoid jumping to conclusions. It simply means something was observed that has not yet been explained. For a long time, such reports were dismissed or kept quiet. But that has changed, and the subject is now discussed seriously, studied by dedicated offices, and reported on openly. It is important to hold this topic gently and honestly. Unexplained does not mean alien, it means unexplained. Most such sightings, when studied, turn out to have ordinary causes. But some remain puzzling, mostly because there is not enough good data to resolve them. Tonight, we will walk calmly through what is actually known, without leaping to grand conclusions, treating it as the careful, open question it truly is, rather than a settled story of any kind. To study these reports properly, the United States government created a dedicated office to investigate them scientifically. Established a few years ago, this office was given the task of collecting reports of unexplained aerial and other phenomena, analyzing them carefully, and trying to determine what they actually are. Its creation marked a real shift. Rather than ignoring or ridiculing such reports, the government set up a formal, methodical effort to examine them, drawing on data from military sensors, pilots, and other sources. The office gathers cases, sorts through them, and works to resolve as many as it can with careful analysis. This is exactly the kind of sober, systematic approach the subject needs. It treats the reports not as proof of anything, but as data to be examined honestly. Whatever these objects turn out to be, the goal is to understand them through evidence rather than speculation. It is worth appreciating how far this represents from the old days of secrecy and dismissal. A serious scientific effort now exists, quietly working through the reports, trying to separate the ordinary from the truly unexplained, and to bring a little clarity to a subject long clouded by rumor and noise. That investigative office receives a steady flow of new reports, now numbering in the thousands over its short lifetime. When it first began, it collected several hundred cases in its early period, and the number has grown steadily since, climbing past a couple of thousand as more sightings are reported and older ones are added to the record. This rising count does not mean the skies are suddenly full of mysterious craft. Much of it reflects the simple fact that there is now a proper place to send such reports, so more of them are being gathered and examined than ever before. When you build a mailbox, you start to receive mail. Many of these cases, once studied, are explained. Others await analysis, held in a growing archive of things seen but not yet understood. The sheer number can sound dramatic, but the truth is quieter. It is mostly a sign of better reporting and more careful record-keeping, a subject finally being tracked in an organized way. Behind the large figure is a patient, ongoing effort to sort through each account and figure out, as best anyone can, what people and their instruments actually saw in the sky. Importantly, after all this study, the official conclusion so far is that none of these cases has been shown to be extraterrestrial. The office responsible for investigating them has stated plainly that its reviews have found no confirmed evidence that any of the reported objects come from beyond Earth. This is a crucial point to hold clearly. Despite years of dramatic headlines and speculation, the careful analysis has not turned up proof of alien craft. What it has found is a mix of ordinary things, some unexplained cases lacking good data, and no confirmed sign of visitors from another world. This does not mean the subject is closed or that every case is solved. It means that, based on the evidence gathered so far, the extraordinary explanation has not been supported. That is the honest state of things. It is neither a dismissal of the mystery nor a confirmation of the wildest hopes. It is simply where the evidence stands, and there is a certain calm in that clarity. The reports are being taken seriously, studied fairly, and reported on honestly, without leaping to conclusions that the evidence does not yet support. When these cases are examined closely, the great majority turn out to have ordinary explanations. Many reported sightings, once analyzed, are found to be balloons, drones, aircraft, satellites, or natural phenomena seen under confusing conditions. Cameras and sensors can be fooled. Distances and speeds are hard to judge in the sky. Reflections, optical effects, and simple mistakes account for a large share of reports. Investigators work through them patiently, and most yield to a mundane answer once enough information is available. This is not disappointing so much as reassuring. It shows that careful study really can resolve these puzzles, and that the sky is not as full of mystery as a quick glance might suggest. Human perception is remarkable, but imperfect, and even sophisticated instruments can be misled. So when a strange light or shape is reported, the most likely explanation is usually something familiar seen in an unfamiliar way. The work of sorting the ordinary from the truly unknown is slow and unglamorous, but it is exactly what brings clarity. And it leaves a much smaller set of cases that remain genuinely unexplained, which are the ones that keep the question interesting. A smaller number of cases do remain unexplained, though usually because there is simply not enough good information to resolve them. When investigators cannot identify what was seen, it is often not because the object was miraculous, but because the data is poor. A blurry image, a single witness, a fleeting sensor reading, none of these may be enough to reach a firm conclusion. In such cases, the honest answer is that we do not know, not because the truth is beyond understanding, but because the evidence is too thin to pin it down. These unresolved cases are the ones that draw the most attention, and it is worth being clear about what they are. They are gaps in our knowledge, places where the information ran out, not proof of anything extraordinary. It would be a mistake to fill those gaps with grand assumptions. The careful approach is to hold them open, to say plainly that they remain unexplained, and to keep gathering better data where we can. Mystery in science is usually just a question we have not yet answered, waiting patiently for enough evidence to arrive. Among the many reports, a few well-known encounters by military pilots have drawn particular interest. In one widely discussed case from the early 2000s, Navy pilots reported seeing an unusual object off the coast, which they described as moving in ways that surprised them. The encounter was captured in part by aircraft instruments, and the footage later became well known. In another set of reports from around a decade later, pilots described seeing strange objects in their airspace with some regularity over a period of time. These accounts come from trained, credible observers, which is part of why they are taken seriously. It is important, though, to keep them in perspective. Even careful pilots can be deceived by unfamiliar sights, and instrument readings can be tricky to interpret. These cases are studied closely precisely because the witnesses are reliable, and some details remain hard to explain. But being unexplained is not the same as being understood to be alien. They remain open questions, examined with care, neither dismissed nor inflated. They are among the more intriguing pieces of the puzzle, and they are exactly the kind of case that a serious, evidence-based effort tries to work through honestly. One pattern that investigators have noted is that some sightings seem to cluster near military installations and sensitive sites. Reports have tended to gather around places like military bases and certain restricted areas. There are several possible reasons for this, and it is worth thinking through them calmly. One simple explanation is that these places are watched far more closely than ordinary skies, with sophisticated sensors and alert personnel, so unusual things are more likely to be noticed and reported there. Another is that such sites naturally attract drones and other craft, some of them ordinary intrusions to be taken seriously for down-to-earth reasons of security. The pattern is real and worth studying, but it does not, by itself, point to any exotic origin. It may simply reflect where we are looking most carefully. As with so much of this subject, the honest approach is to note the pattern, consider the ordinary explanations first, and keep gathering data. What looks mysterious at first glance often has a practical root, and separating the genuinely puzzling from the easily explained is the patient work at the heart of the whole effort. Recently, the effort to be open about these matters took a large step, as the government began releasing files to the public. Under a new program, officials started to declassify and publish records related to these unexplained sightings, making documents, images, and videos available for anyone to examine. The idea was to offer transparency, to let people see the material for themselves and make up their own minds, rather than leaving everything locked away. The files include historical reports going back many decades, accounts from pilots and other observers, and various records gathered over the years. Some of the material is striking, some of it is mundane, and much of it is incomplete or hard to interpret, as such records often are. Releasing it openly is a notable change from the secrecy of the past. It does not resolve the mystery, and it does not contain any confirmed proof of alien visitors. But it puts the evidence, such as it is, into the open air. People can look at the same records the investigators do, which is a healthier situation than rumor and secrecy. It reflects a slow shift toward treating the subject as a matter for honest public study. Among the released material are some curious historical accounts, including notes from astronauts and old military files. The archives contain a wide range of documents from across the years, some of them decades old, touching on sightings reported by pilots, by people on the ground, and even, in a few cases, by astronauts recalling unusual things they noticed in space. There are old reports from the era of early spaceflight and records tied to various incidents over many years. Reading through such material, one finds a mixture of the intriguing and the ordinary, accounts that raise an eyebrow alongside those easily explained. It is a reminder that people have been reporting strange things in the sky for a very long time, and that most of these reports, then as now, likely have earthly explanations. The historical files are fascinating as a record of human observation and curiosity, of how we have long looked up and sometimes seen things we could not immediately name. They do not settle anything, but they add texture to the story, showing that the impulse to notice and wonder about the unexplained is nothing new, and that we are simply examining it more openly now than we once did. To bring more rigor to the subject, scientists have begun to get involved, applying the tools of careful research. Rather than leaving the topic to rumor and speculation, researchers and academic advisors are being brought in to help study the reports with proper scientific methods. The aim is to gather better data using well-designed instruments and clear standards so that future sightings can be measured and analyzed rather than merely described. Good data is the thing most often missing from these cases, and improving it is the surest path to real answers. This scientific involvement is a healthy development. It treats the question with the seriousness it deserves while insisting on evidence and rigor rather than excitement. The guiding principle is simple and sound. Unexplained does not mean alien, and the way to resolve a mystery is to study it carefully, not to guess. If there is genuinely something new to be found in these skies, disciplined science is the way to find it. And if the reports all turn out to have ordinary causes, disciplined science will show that too. Either way, the calm, evidence-based approach is the one most likely to lead, in time, toward the truth. Setting the recent reports aside, let us turn to a gentler and more imaginative question. If life does exist out there, what might it look like? Here we leave firm knowledge behind and enter the realm of careful speculation, which is its own kind of pleasure. We have only one example of life to study, our own, so any guess about alien life is uncertain, but scientists can reason thoughtfully about what might be likely based on the principles that shape living things here. One useful idea is that certain features may arise again and again wherever life evolves because they are simply useful. On Earth, for instance, eyes have developed independently many times in different creatures because sensing light is so valuable. So it is reasonable to imagine that life elsewhere, if it becomes complex, might also evolve some way of sensing its surroundings, some form of symmetry, some means of moving and feeding. These would not look exactly like ours, but they might rhyme with them. It is a soft and pleasant thing to ponder as you drift, the idea that life, wherever it arises, might solve some of the same problems in some of the same broad ways. The pull of gravity on a world would shape the size and form of any creatures living there. Gravity is one of the quiet architects of life. On Earth, it sets limits on how large and heavy an animal can grow, how sturdy its legs must be, how its body holds together against the constant downward pull. On a world with stronger gravity than ours, life might tend toward low, thick, powerful forms, hugging the ground, built to bear their own heavy weight. On a world with weaker gravity, the opposite might be true, and creatures could grow tall and spindly, or large and light, in ways impossible here. Gravity would influence not just size, but movement, whether life crawls, walks, swims, or drifts. So when we imagine alien creatures, we should picture them shaped by the pull of their own particular world, not by ours. A being from a heavy planet and one from a light one might look utterly different, each perfectly suited to its home. It is a gentle reminder that form follows circumstance. Life, wherever it arises, is molded by the quiet forces of its world. And those forces vary from planet to planet in ways that would give each living world its own distinctive shapes. On a world with crushing gravity, life might stay low and broad, built close to the ground. Imagine a planet noticeably heavier than Earth, where every step would feel like carrying a great burden. Any large creatures there would likely need to be compact and strong, with wide, sturdy limbs to support themselves, keeping their bodies low so that a fall would not be so dangerous. Tall, delicate forms would struggle under such a weight. Instead, we might expect flattened, powerful shapes, hugging the surface, moving carefully and deliberately. The very posture of life would be pressed downward by the heaviness of the world. It is fascinating to think how differently a living thing might be built simply because its planet pulls harder. The same principles of physics that shape a creature's bones and muscles here would still apply, but the answers would come out different, tuned to a stronger pull. A being from such a place, if it exists at all, might seem squat and solid to our eyes, unhurried in its movements, superbly adapted to a world that would leave us struggling just to stand. Nature, given a heavier hand, would sculpt life accordingly. On a gentle, low-gravity world, or in a deep ocean, life might grow vast, delicate, and floating. Picture the opposite of a heavy planet, a world where gravity is soft, or a deep sea where the water itself bears much of a creature's weight. In such places, life could grow to enormous sizes without collapsing under its own bulk, and it might take on airy, sprawling, graceful forms that would be impossible under a stronger pull. On Earth, the largest animals live in the sea, buoyed by the water, freed from the full weight of gravity. On a world with weak gravity, or in a thick atmosphere, we might imagine great drifting creatures, light and expansive, moving slowly through their medium like living clouds. It is a beautiful thought, gentle and dreamlike. Somewhere, perhaps, life floats rather than walks, huge and soft and unhurried, sustained by an environment that cradles it. We have no evidence of such beings, of course, but the physics allows it, and the imagination delights in it. As you settle deeper into rest, you can picture those vast, drifting forms, moving with slow grace through a distant sea or sky, weightless and calm. Despite what films often show, alien life would probably not look much like us at all. It is natural to imagine aliens as roughly human-like, with 2 arms, 2 legs, and a face, because that is the shape we know best. But there is little reason to expect life elsewhere to resemble us so closely. Our particular form is the result of a long and specific history on this one planet, full of chance events and local conditions that would never repeat exactly anywhere else. Life on another world would follow its own path, shaped by its own environment and accidents, and could end up looking utterly unfamiliar. It might not have a face as we know it, or limbs arranged as ours are, or any feature we would recognize. And in truth, the most common life in the universe is probably not large creatures at all, but tiny, simple organisms, more like microbes than like anything from a story. If we ever find life beyond Earth, the most likely form it will take is small and humble, a smudge of living chemistry rather than a walking, talking being. The real thing, whatever it is, will almost certainly surprise us. If we ever meet intelligent alien life, its mind might be as strange to us as its body. We tend to assume that intelligence elsewhere would think somewhat as we do. But even on Earth, minds can be remarkably different from our own. Consider the octopus, a creature with a large part of its nervous system spread through its arms, sensing and even deciding in ways quite unlike a human brain. It is clever, curious, and capable, yet its intelligence is built on a completely different plan than ours, evolved along a separate branch of life. If a mind so alien can arise right here on Earth, imagine how different a truly extraterrestrial intelligence might be. It might perceive the world through senses we lack, think in ways we could scarcely follow, value things we would never guess. Communication might be difficult, not because they are hostile or hidden, but simply because their way of being is so far from ours. This is a humbling and fascinating thought. Intelligence may come in many forms, and ours may be just one small variety. The universe, if it holds other minds, may hold kinds of thinking we can barely begin to imagine, each strange and whole in its own way. There is a sobering idea that might help explain the silence, sometimes called the Great Filter. The thought goes like this: for a planet to produce a civilization that spreads across the stars, many difficult steps must all be passed. Life must begin. It must grow complex. It must become intelligent, develop technology, and survive long enough to reach outward. At any one of these steps, there might be a barrier so hard to cross that almost nothing makes it through. That barrier is the Great Filter. If it lies in our past, in some rare step that life on Earth was lucky enough to pass, then perhaps we are unusually alone, and most worlds never get this far. If it lies in our future, in some challenge yet to come, that is a more sobering thought. We do not know where the filter is, or even whether it truly exists. It is a hypothesis, a way of thinking about the silence, not a proven fact. But it is one more gentle possibility to hold. Perhaps the road from lifeless rock to a voice among the stars is simply far harder than it looks, and the quiet sky reflects how few ever travel the whole way. Scientists genuinely disagree about whether life like ours is common or rare, and both views are held by thoughtful people. On one side is the idea that Earth may be special, that the particular combination of conditions that allowed complex life to flourish here might be uncommon in the universe. A stable star, a protective giant planet nearby, a large moon, the right chemistry, long stretches of calm, all coming together just so. Perhaps such a fortunate arrangement is rare, and complex life is scarce. On the other side is the view that there is nothing very special about Earth at all, that our world is ordinary, and that where the same conditions occur, as they surely do in countless places, life will tend to arise. By this thinking, the universe should be full of living worlds. Both positions are argued seriously, and the honest truth is that we do not yet know which is closer to reality. We have only our single example to reason from, and one example cannot settle the question. So the debate continues, calm and unresolved, a genuine open question at the heart of the search. waiting for the evidence that might one day tip the balance one way or the other. Whatever the answer turns out to be, it would be one of the most profound discoveries in human history. Think about the two possibilities. If we learn that we are truly alone, the only living world in an immense and silent cosmos, that would give our existence a rare and precious weight and place a great responsibility on us as the universe's only known witnesses. But if we learn that we are not alone, that life stirs elsewhere among the stars, that would change forever how we see ourselves and our place in things. Either answer would be staggering, and either would reshape our understanding of everything. That is part of why the search matters so much, even though it moves so slowly. We are not merely collecting facts about distant worlds. We are working patiently toward an answer to one of the deepest questions we have ever asked. And whichever way it falls, alone or not alone, the finding would ripple through every part of how humanity understands its own story. It is a question worth asking carefully and worth waiting for, however long the waiting takes. Few questions could ever matter more. In the end, perhaps the most beautiful part of all this is the wondering itself. We may not know whether we are alone. We may not know for a very long time. But the fact that we can ask the question at all is remarkable. We are made of the same elements as the stars, arranged by chance and time into beings that can look up at the night sky and wonder about their own origins and their own company in the cosmos. In a real sense, we are the universe becoming aware of itself, gazing outward and asking whether anything else is gazing back. That is a quiet marvel, whatever the answer. The searching, the listening, the careful looking, all of it is an expression of something deeply human, the desire to understand where we came from and whether we are alone. And there is a gentle comfort in that, in belonging to a species that keeps its eyes open and its questions alive. Tonight, you are part of that long, patient wondering, simply by lying here and letting your mind drift out among the stars. And that, in itself, is a lovely place to be. Let the facts settle behind you now, like pages closing at the end of a long evening. You do not need to follow them any further. You do not need to remember every distant world, every strange chemistry, every careful, unanswered question. Let them drift away into the soft dark where they belong. The stars will keep turning whether or not we understand them. The great dishes will keep listening while you sleep. The visitors from other suns will keep drifting quietly through the deep. And the searching will go on without any effort from you at all. There is nothing left to do tonight but rest. Let your breathing slow. Let the room grow still and warm around you. Let the weight of the day sink away, and let the wide, gentle cosmos hold you for a while. If this quiet kind of science helps you find your rest, you are welcome to return whenever the night feels too loud, and another calm video will be waiting when you are ready. But for now, let the questions grow distant, let the stars grow soft, and let yourself drift. Sleep well, and good night.